Howdy, everybody. Hope you're doing well wherever, whenever you are. Sorry, I had my window open. Did you hear the car go by? I've tried to add filters and stuff like that. We'll see what happens. Anyway, things look a little different. Just trying some different things out. But we're here for day 23 of Advent to Code. We're seeing if we can't, learn and grow, prep ourselves mentally for the upcoming advent of code. Just puzzle solving in general. I like puzzle solving. I had to do like a getting to know you thing last week for work, and one of the things I mentioned is I like puzzle solving. It's kind of fun to do, right? So anyway, here's where we are. Here's what we're doing. I don't think I have anything else. I appreciate all your comments and stuff like that, but would love to hear, your thoughts on things and what things you've done to help improve. Those would be great as well. So otherwise, let's just get started. So it is day 23 again. We're opening the Turing lock. Okay, like a Turing machine or something. Little Jane Marie just got her very first computer for Christmas from some unknown benefactor. It comes with instructions and an example program, but the computer itself seems to be malfunctioning. She's curious what the program does and would like you to help her run it. Okay. The manual explains that the computer supports 2 registers and 6 instructions. Truly, it goes on to remind the reader the state-of-the-art technology. Yeah, okay. The registers are named A and B, can hold any non-negative integer, and begin with a value of 0. The instructions are as follows. I'll just say, if you've done computer science courses, I think mine was like computer architecture, is called something along those lines. You'll implement these type of things, right? Where it's like, okay, you're going to have some limited set of registers and then some simple instruction set, and can you create a system to run programs to do that or whatever, right? So the instructions. Half R sets the register R to half its current value, then continues with the next instruction. Tuple R sets register R to triple. Okay, triple its current value, then continues with the next instructions. Inc R increments register R by adding 1 to it, then continues with the next instruction. Jump offset is a jump. It continues with the instruction offset away relative to itself. Okay. Like jump if equal or something like that. Oh, even. R offset is like jump, but only jumps if register R is even. Jump if even. Jump if odd, I guess. Yeah. No jump if 1. Okay. R offset is like jump, but only jumps if the register R is 1. Jump if 1, not odd. Got it. So we have a jump if even, jump if 1, jump offset, increment triple and half. A relatively small instruction set. All 3 jump instructions work with an offset relative to that instruction. The offset is always written with a prefix plus or minus to indicate the direction of the jump, forward or backward, respectively. For example, jump plus 1 would simply include or would simply continue with the next instruction. Jump plus 0 would continuously loop back to itself forever. No bueno. The program exits when it tries to run an instruction beyond the ones defined. For example, this program sets A to 2 because jump IO instruction causes it to skip the triple instruction. Non-negative integer. Sorry, I was just looking there. So inc A sets A to 1. Jump if odd. Jump if 1 A plus 2. So A is 1. So we'd go plus 2. 1, 2. Inc A. So A is now 2. What is the value in the register B when the program in your puzzle input is finished executing? And then here's our little program. Okay. We've implemented this before, and I've done a partial. This reminded me we've been doing the int code computer. I don't think I finished that. That might be something worth going back to. But anyway, here we've got our instruction, what to do and where to go. Jump -7. Do we want to use like nom for this? I want to get more used to using nom anyway, so maybe we should try it. Just so like people are aware. This is nom, and it's a parser library. We've used it before, but I haven't used it in a year or so. But the idea is you can say, hey, here's how I want you to parse the string, and you use like these parser combinators. Oh, here, this is probably the best way to look at it. Well, maybe not. But like you say, okay, I'm looking for A and ABC. It will parse out A and then leave you with BC. And there's ways to like combine all these things. So maybe we try and use nom for this. These instructions aren't too difficult, but let's try it. Okay, so we have 2 registers, non-negative, so they'll be U sizes. But we may subtract values, offsets, right? Oh, that's only the program counter. So the program counter can be an I size. These offsets are going to change the program counter. Like the way you set up a computer is you'd have your registers, which is like, you can think about like your really low level memory on like the CPU, and then your CPU is running instructions, these instructions based on those register values and stuff like that. But it also has when it's running, you have a program counter that's telling you like where in the instructions you are. And so these offsets are going to modify those instructions. Because it'll be in a list like a vector, I think we still want the offset to be a U size for the program counter. Or not. Because it says if it ever falls off, it's not clear to me that it would fall off negative, but there's a potential that a program could set the offset to a negative value. I mean, it won't in my program, right? The only negative jump is right here. This is jump 7. -7, so it's like somewhere up in this range, right? Somewhere in here. So we would never experience that, but it's possible that it could. Anyway, let's just get programming, see if we can't figure this out. So we want to create some things, some structures first, I think. So we want a enum for the register, and it's going to be A or B. I think I have I need to cd advent of code cargo add nom. Okay, so we have nom, so we have these 2 registers. And then we'll have our instructions. So we'll have an enum instruction, and they are half register, triple register and increment, and then we have jump, which is a Yeah, I kind of want to have a sign and a offset. So like determine. What did I decide? Yeah, there's ways to do this. If you're sure that it's never going to like go above, you're okay, right? Or below. Sorry, go below 0. But because you're like adding and subtracting, I sort of think we want these to be the offsets to be an eye size, and then we'll just cast them when we do our thing. Okay, so we have a JIE with a register R offset jump if even with a register and an eye size, and then a jump if 1 with a register and an eye size. So now we just need to worry about like parsing these, right? We say to ourselves, how do we parse these? So we say impl register fn parse, and we're given a input stir, and we're going to get a result from nom. Right, is that right? Oops. I result is what it's called. And this should give us a register and a stir and a register. And so to parse a register, we're looking for A or B, right? They are lowercase. So I think if we do one or other, like we can say car A or car B, like we're matching exactly character A or character B, and then we do this alternate. So we'll try A for A or B. But we need to do there's like a map one somewhere in here. Did I miss it? So we're going to map this like that. So it'll be alt. And then we have our 2 different values. One is going to be a map of car A goes to a function that you give it a stir and okay. Like that? Oh, I need to do Oh, I guess I can just use tag too. Like that. This is what's changed, is this parse thing has changed since I've used it last. Okay, so I think that's right. That'll give us our register. So now we want to parse the instructions. How do I join them together? Like, because the next instruction, the next thing I want to do is the equivalent of saying, oh, if I have half and then a register, half space register. Do I just ask AI this? I mean, I don't know enough. Delimited, preceded by. Is there some kind of like. Like, what I want to do is create a sub parser. Okay, well, maybe I will ask. Gemini. Oops. I want to create a parser in nom for. We'll just have to do a lot of more nom practicing. Something went wrong. What? Yeah, okay, I got this part. Got this part. Got this. Do one for parse offset. Wait, how am I parsing the instructions? Parse instruction is where. I mean, this looks exactly like what I have. Oh, here it is. Okay. So it's suggesting create one for each of them with preceded. Preceded, tag, parse, reg, and offset. Okay, so we're basically we're going to create functions to do it in parts and go from there. Okay, so we'll try this out, see how far I get. But I definitely have this parse register, which is good. So now we can have we'll create some of these. So we'll have fn parse half, where we give you input stir, and I'll give you, is that right? That's what it wanted me to do. Yeah. What is input? Oh. I don't think that matters. Hopefully not. And I get an I result of instruction and a stir. Oh, but I think it goes the other way, right? Is that right? Yeah. So now this would be, it used preceded. Is that right? Map preceded parse register instruction half. Is that really right? So what is it saying? Map is like, you know, map this to this. And then preceded tag. What is the preceded? Let's go look this up. Matches an object from the first parser and discards it, then gets an object from the second parser. Okay, so yeah, oh, gotcha. So it's finding this, ignoring it, and then using this. Okay. So presumably I do that for half triple ink. So I have half triple and ink. Triple, 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 ink, ink, ink. Those are all registers, right? And now I have a jump offset. And this one's going to be a map proceeded with the tag oh, I should call it jump, huh? Jump. And it's going to give us an offset, which is an eye size. So is there an eye size? Nom character complete eye size. Nom character complete eye size. Instruction jump. Parse. Like that. I think that's what it's saying. We look for the jump, convert it to an eye size, and call instruction jump. Okay, so now we have jump if even and jump if one. So these are going to be close. Jump if even. Ooh, but there's gonna I want to do 2 parts. So do I use the tuple? What it hit? Parse reg and offset. Okay, so create a helper function that does the thing. Is that right? Separated by a comma. Yeah. So we'll do that. Is this actually faster? I mean, maybe it will be once I know more about it. Oh, this is actually going to return a register with a nice size, right? So now I say, now here, I say parse reg and offset like that. Mismatch. Expected function signature register eye size found function signature. Oh. Still not? Where's my... Oh, is that right? What am I doing wrong there? have to do it manually here, so I have to go. That's what it's saying. Okay. So we have jump if even and oops. Jump if odd. And so now I do a parse where I can basically combine all these. And that looks like what? Which one? Proceeded, terminated. No. Is there like the equivalent of first? Permutate, delimited, proceed, terminated, count, many, 0. Oh, it's just alt, isn't it? I think I've done it before, right? Alt. Try a list of parsers and return the result of the first successful. Yeah. So I'm just going to do, this one is literally, oops, alt. And we're going to do self parse half. Self parse tuple or triple, self parse inc, self parse jump, self parse jump if even, self parse jump if one dot parse input, like that. So now I could do a fn parse all with the input stir and have an I result for stir vec instruction. And is there like a parse mn or something like that? Parse or like parse. Separated list. I think it's just this, right? And we'll do it by new line. Like that. So presumably now for part one, I can say let instructions equal instruction parse all input unwrap print line instructions. probably didn't implement debug. Or derive it. Panicked on line 97. Error value incomplete size 4 note run with. Incomplete size 4. The heck does that even mean? Parse all unwrap. So something about my parser's not working. We could just try them one at a time and see if a specific one's failing. So we could say input.lines.map L. We call instruction parse L unwrap. Oh, it didn't like it because of this. That actually works. Oh, what? Oh, I think I've seen this before. Like, because there's a new line at the end of it, it doesn't like the parse alls. Okay, well, I'm just inclined not to use this then. I think I've seen this before. It's like, because the last line has a new line, it's going to try and parse one more time. I think there's a way to get around it. I mean, you obviously just strip the last new line, but there's another function you can call that says like skip if empty or something along those lines. But yeah, we basically just do this. And then we should be good. So now, okay, so now we have the instructions. So we just need let mute program counter A and B equal like that. And we're just going to run the program, I presume. They both start at 0, and we only end when it's over. So we'll say while PC is less, or sorry, greater than or equal to 0, and PC is less than instructions.lang. We're just going to keep running it. So we'll say match instruction PC as usize. Oh, it's instructions. So instruction half. Like that. Oops. So that's the one for half. And oh, we're going to return the value of B, right? At the end here, which is U size. Okay, it just doesn't like that I don't have all the patterns. So we have half, triple, and increment. Like that. And then we have jump, which is an offset. And for this, we just say what's happening here? Program counter plus equals O. Like that, right? Expected U size, found I size. So now we have a jump if even with a register and a thing, and we say match our register A goes to if a modulo. Oh. We can probably simplify these things in a minute. Now we need to do the jump if one. Oh, it's not zeros. Cannot move. Move occurs. Doesn't have a copy. Is it stuck? It's running forever. Is that because I'm dumb or... Oh, I know what it is. In these cases, I want to increment the register. Sorry, the program counter. So I want to do like oops. Something like this. So I almost want to write like a handle function up here to like just do this thing. I don't know. We can clean it up later. This looks really ugly, I think is what I'm thinking. I really don't like this. Like what you'd usually do is, maybe what you could do is say like, put it down here afterwards. I don't remember what we've done in the past. But anyway, we can... like that. So I need to do it for this one too. Oops. Oh, this one is interesting because it's here in the else's. Like this. Yeah, that does look really ugly, but okay. We can clean it up later. So what are we doing? We want to increment our program counter. I mean, presumably we do it. Oops. Here. We perform the instruction, but now we need to increment our program counter. Obviously, for jumping, we're not incrementing. The jump ifs, we only increment by one, you know, if it's not true. So I think that does it. Hopefully. 307. It runs pretty fast too. That's the right answer. You're 1 gold star away. Okay, not too bad. Spent a lot of time, you know, writing the code and parsing it. Presumably, if you were trying to speed do this, I mean, I think you just split by space, right? But anyway, let's move on to part 2 and see how things look. The unknown benefactor is very thankful for the releaser helping little Jane Marie with her computer. What is that? For release. Okay. Definitely not to distract you. What is the value of register B after the program is finished if register A starts at 1 instead? Okay. So I'm tempted to say P1 is solve input 0, and this is solve A is a U size. Like that. Presumably that still gets you oh, we'll call this run. Like that. I presume I get the same answer. Anyway, okay, so let's go to P2, and then it's just run input 1. U size 160. What is this releasing thing? That's the right answer. Okay. I mean, it doesn't feel like day 23 was too hard. It took me 45 minutes. Most of it was the parsing part of it. Again, I think if you were using another language, or if you were just like, oh, I'm just going to parse the strings as I get to them, it might be faster. We chose to use nom, try and learn nom, and that probably took most of my time. But the actual logic of processing it isn't too hard, right? So let's do some cleaning up, though. We can move this right here. Maybe move all this. Well, yeah, that's can keep it right here like this, I guess. Yeah, so again, these parsers, this may not be a good case for using nom. What does the input look like? Again, like you're really just imagine you're just taking each line and splitting by space, and you trim off commas, and then you say if it's JIO, is this an A? Like I can show you what that would look like. I actually think it's going to be faster, so or less verbose. So how would we do that? I mean, for the instruction, we just say, hey, you give me, and this isn't going to be as robust, I guess, as using nom. Maybe that's one way to say this is like, if you want it to be robust and do error handling and stuff like that, because I think we'll just say, you give me this, I'll do self, and then we'll just say, I mean, that wasn't necessarily any fewer lines of code. But I think these ones will be, right? This one at least will be. Because we can say, let Oh, we're going to return an instruction. And we'll say let parts equal input dots. We split on space and we collect into a vec. And then we do match parts 0. And if it's half, we return instruction half, or sorry, HLF, and we do register parse parts 1. Tipple inc. So then we have jump. Oh, I didn't change these either. Tipple inc. Now we have jump. And we want to do parts 1 dot parse eye size unwrap. So like you can see, this is clearly going to be like simpler, but it's going to be less error handling. In our case, we don't really care, right? And you could even make a case like right here to do some error handling. Right here, you could say, panic, invalid register. Because we're puzzle solving, we can say, oh, I'm going to throw this if I have an issue. Okay, but now we have these next ones, which is like jump if even. And it's going to be, trim end matches, comma. The first one's going to be the register. So that's this. And then the second one is going to be parts to parse eye size unwrap. And this is jump if even, like that. And jump if 1. It's going to be the same. And then otherwise we'll panic. Unknown instruction. Something like that. Unknown register. Like that. So now when we have the run, we just call parse. And the rest of this shouldn't change. Yeah. I mean, that gives us the same number. So what is that all to say? I mean, maybe nom wasn't the best way to parse, to use this for parsing, because, I can use like this, and then I can use like this, and this is clearly simpler, right? Probably more readable. I think it probably depends on the complexity of the input. But the more I've been doing this, I really want to use nom because I think it's really cool. But it's just the ability to do this when you're puzzle solving is so much easier. Maybe the way to say it is if I was like doing this at work and I needed to be, you know, robust and handle cases where there's spaces or not spaces after commas, things like that or whatever. But because I know the input relatively well, maybe that simplifies it. This one I actually think we can simplify to this, right? So how do I simplify these? Like I can definitely say for an instruction, if I give you, you know, program counter A and B, can you do these things? I can even do this part right here, right? So like, for example, up here in the register, we can say fn increment on self mute A mute B. Oh, it's gonna something like that. I need dereference here. So I can do this increment half and triple. Oops. Okay, so like they're not being used now, but presumably now I can just say no, I actually don't know which register it is at a given time. Oh no, I do. It's right here. So I can say r dot this can be replaced with r dot half. Like that. Presumably it works the same way. Nope. That broke it. Am I doing that wrong? Oh, divide by 1. Rip. Yeah, there we go. Okay. So that will make this look a little bit better, I think. Can I do these as well? I can just ask if it's even. So oh, I need to give A and B as well here. And then I can do 1 as well. Like that. So now these ones I can now say it's like if r dot even AB like that. Okay, that's starting to feel more readable. Yeah, you could probably even further simplify this by having just a program with registers. I don't. All of this kind of depends on how you feel, right? Imagine this being like a hash map of registers, so you can just like pull it out and ask the questions what they are and what the values are. That might make this even more simpler, so you don't even have to do these. The question is like, how much do you like your type system, right? So having a register here where you can enforce types. Yeah, so you could even potentially move this here, right? So for the instruction, we could have an fn evaluate where we have a self. Looking a little uglier because we have to use, we have to dereference all this stuff. But I mean, it's not terrible. Okay, so if we just do instructions pc as isize dot evaluate like that. What doesn't it like? Oh, it's because they're already mutes. Okay. I mean, that makes the run look simpler. You just call evaluate, and the evaluate does all the work. Okay. We've been going for an hour, so I think I'm going to leave it at this. I'd love to see what you think. How you solved it as well. So send me your solutions, or maybe the things you did to make it simplify the work. Again, I think especially if you're saying, oh, I don't really care about the type system, I'm just going to look for strings. It may have even been simpler to solve this, at least from like a code length size. So if you did that, I'd definitely be interested in seeing that. Anyway, I think that's it. So thanks, everybody. We'll talk to you next time.